Hey guys, Pujar Green with episode 7 on the Arduino laser tray. In this episode, I'm going to start off by sketching the Arduino to identify foreign objects and firing the laser, targeting on them and hitting them. Lastly, I'll finally end this project by coding it to only activate as soon as a PIR motion sensor detects motion. Let me show you the sketch. Once again, the sketch doesn't change much until the end of the setup function. The only thing I change is I include two more variables for the angles of range, which are the range minimum and the range maximum. This is the range of the sonar, the servo motor. Also, something I amended and must refer to is initially I was working on the distance array as an integer variable, although the distances are measured in as a float variable. So I was wrong and I changed it. I accordingly making it a float variable. And like I said, nothing changes until the end of the setup function. The loop, though, is very different. Since the task of comparison is too much for a for loop, I had to use the nature of the loop's function as the biggest loop to achieve the set goal. The whole sketch is a measure comparison and executing due process, then moving up one rotator step and repeating from the beginning. And after knowing that, the sketch is much easier to understand. So we start in position 0 and map indexed 0 and take a measurement. Afterwards, in this if block, we will compare the measurement taken with the maps value. We will do that over here under this condition. So, if the measurement taken is higher than the maps array plus the sonar resolution, or if the distance measurement is lower than the maps value minus the sonar resolution, and if that distance measurement read is different from 0. If this condition is met, that means we have a foreign object and the laser will fire for 2 seconds. Afterwards, shutting off. Next, we increment the maps index, the rotator's position, and let the sonar stabilize. Then, we check if the rotator reaches the maximum range defined by the variable. It will enter into this for loop and return to its original position. Also, resetting the distance maps index back to 0. Now, let's see the sketch in work. I've uploaded the sketch and now I'll hit the reset button so you can see the sonar scan and build a map. Next, I'll let it run and you'll see the laser light on the critical point where the sound finds it hard to reach the ultrasonics input sensor right here. Let me show you that again. This is the critical point. Now, let's place an object in front of the sensor to see how it behaves. And looks like the sketch does its job. Even if the distance is bigger than the one mapped, like opening this door, let's see. As you can see, it works. As long as it respects the capacity of the sensor, which is from 2 centimeters to 400 centimeters, the Arduino and the sketch will do its job. So let it run one more time so that you can see the sonar will only fire on the critical point. There you go. It's working. It's finally time to include the motion sense into the sketch. Until now, this is actually the easiest part. Let me show you how I did it. The sketch is exactly the same as last one, with 2 additions. One of them is the inclusion of this variable activity. This will serve to indicate and allow the loop to run until the scan and target mode has swept the whole range. The other addition I made was this block right over here. This condition guides the sketch into the standby mode. If the activity, which I start off as 0 over here, if it is 0, the sketch will enter this do function and will keep on reading until the motion sensor is in a low state. As soon as the motion sensor detects activity, it will leave the do function and will turn the variable activity and set it to 1. That will let the whole sketch run just like the last one, the laser, and scan the whole area until it has reached the position of the maximum range. As just like last time, it will enter this for loop, returning to the original position, returning the distance index to 0 and the activity variable to 0. And this will allow the sketch to return back to reading and waiting until the motion sensor detects activity. So now that you've seen how the sketch looks, let's see this working. I already uploaded the sketch, and I'll hit the reset button over here so you can see it start from the beginning. The sonar is scanning the area, and afterwards it'll wait here until movement, as you can see. Now just let me grab an object. If I move an object in front of the sonar, it'll detect movement and start working, as you can see. And while I have the object in front, it'll keep on firing the laser. If I take it out, it'll proceed to do the full scan and then return back to its origin point and wait for new movement. This project, the Arduino Laser 2-Ray, is now complete. Now, does this mean that it's done for? No. I'm planning further upgrades for it. For example, with my HC05 Bluetooth module, I can connect it to my cell phone and receive the data and have it transmitted and see it on my cell phone screen. But that and a lot more is content for another video. Until then, thanks for watching.